today's video, we're going to go over some more advanced soldering techniques, as well as some troubleshooting tips. So let's get started. One of the first and most important things to learn when soldering is to make the solder work for you. As you solder more and more, you'll learn to control the way the solder flows. With this, we're just going to create a simple solder blob. You'll learn how it behaves and how it reacts to certain heat and movement. You can see how the iron controls the solder as it pulls it and cuts and divides in this blob form. When you heat it up, it's a nice smooth metallic surface. As it cools, you'll see it turn to more of a chrome surface. Another factor that will help you improve your soldering skills is learning to use different tips for different applications. In the center is the conical tip. It is by far one of the most versatile and useful tips. On the left we have the bevel tip, which is flat on either side. The flatness allows you to get into tight crevices, much like a fine-tipped conical tip. On the right, we have the hoof tip. The hoof tip is much more suited for SMD soldering, which we will go over in another video. Here we have two different gauge solders. On the left, we have a larger width, smaller gauge solder, and on the right, we have a smaller width, larger gauge solder. Here we're going to solder a barrel jack onto an Arduino Pro. For soldering on this type of component, both sizes of solder would work. However, as you can see, the larger width, smaller gauge solder makes it easier and faster to solder the barrel jack on. As with any solder joint, be sure to apply heat to both the leg and the pad as you're soldering, and simply let the solder flow into the through hole. Here we have two LED boards that we want to connect together. Rather than use stripped wires or clipped leads to make the soldering connections, we're just going to use solder. First, we're going to apply little dabs of solder to each of the through holes. Then we're going to slowly build each one up with more solder progressively. Once the two sides are of equal height, we can now start to bridge the solder over with the iron. The trick here is using heat. As it cools, the solder will tend to form more to the shapes that you desire. However, if it gets too hot, it will want to form to its natural shape of a simple blob or a cylinder down in the through hole. With the first one finished, we bridge the second two. With the second two finished, we have our connection made with nothing but solder. As you're soldering, you'll notice that the tip of your iron will begin to oxidize. This will become more apparent as the solder will not want to adhere to your tip as much as it was. It will also become dull in color. Tip tinner is a chemical paste that rejuvenates your soldering iron tip. Lightly submerge the end of your wand into the tinner. With a quick brush on the brass sponge, your iron tip is good as new. With extended use of a soldering iron, the tip will deteriorate and develop holes. Once this happens, the tip should be replaced as soon as possible. Here we have two wires that we want to solder together. In order to make this process even simpler, especially with lead-free solder, we are going to apply some flux. Flux is a chemical compound that comes in a liquid form. As we were soldering our solder blob, you may have saw a liquid residue left over. That was the flux core coming out of the solder. We also have what we call the flux and touch method. So I'm going to apply some solder to the tip of my iron and simply touch it to that connection. The flux pulls the solder in and around the two joints that we wanted to connect and gives us a nice solid solder connection. Flux can also come in handy when soldering through-hole components. Ground pins are particularly stubborn because they sink more heat than the rest of them because the heat is drawn into the ground plane within the PCB. To remedy this, we simply dab some flux onto that stubborn pin and apply more heat to get a perfect solder joint. Here we have an Arduino shield. We're going to take our headers and place them to where they're going to be soldered. When soldering multiple components in at the same time, it's easier to use some sort of platform to help you flip the board over with all of the components in place. One of the most important parts of this is to always tack down one pin of whatever component it is you're soldering first. This allows you some flexibility to straighten and level parts before you solder them. And for components with polarity, it gives you a second chance to double check that the component has been placed in the board correctly. Here we see one of the headers is slightly askew. To fix that, heat the one corner you tacked down, use your free hand to move the header into the correct position, remove the iron, and let it cool. Once all of the headers are aligned correctly, finish soldering the rest of the headers onto the board. One of the most important things to keep in mind when through-hole soldering is to work from the lowest profile part to the highest profile parts. The purpose of this is to make it easier to solder on each component. Components like resistors and ICs tend to not stick up very far from the surface of the PCB. If we solder on all the tall components first, the lower profile parts are going to want to fall out as you solder them. On this particular board, the 7-segment display and the IC are of equivalent height, so we soldered them on at the same time. The push buttons were also all equal height, so we soldered them on. Lastly, we will show you the two highest profile parts, the switch and the buzzer. Just as before, we solder each one on, attacking one leg down first to ensure that they are properly aligned and level. Once they are, we finish the solder up and we have a completed through-hole board. If you happen to not work from lowest to highest, there is a trick for keeping components in place. Bending the legs of the components allows them to stay in place as you solder. The trick is to only bend them a little so the part stays in place, but not so far that the legs will be difficult to trim when you're finished. We want to solder one leg of each component first so that we can go back and push them down so they are all level. Once they are all level, we go back and solder the other remaining legs. While soldering, there's plenty of room for error. I've placed 2 jumpers here on the headers. All you need is a little bit of solder wick and a clean iron tip. Placing the solder wick in between the 2 pins and heating it with the iron sucks up the excess solder. Be sure to remove the solder wick quickly as it will dry and stick to the pins. Cold solder joints happen when heat is not displaced correctly and is either concentrated on the leg of the component or the through hole, thus leading to an uneven solder joint. Some cold solder joints miss the connection entirely, whereas some merely fill in half of the hole. Both of these can be remedied by using the flux technique we showed earlier. Simply dab the flux pin on the cold solder joint, heat it with the tip, and apply more solder if necessary. Here we have an LED that has been placed incorrectly. Using the iron, we heat both of the legs simultaneously. Using tweezers, we can pull the LED as we heat up both legs. You can also use hemostats to get a better grip on the component you're pulling out. Once the component has been pulled out, you'll notice that there's still excess solder left in the through holes. One of the more common tools used to remove this excess solder is called a solder vacuum or a solder sucker. The easiest method is to apply heat to one side of the hole while using the vacuum on the other side. Another way to use the vacuum is to trigger it from the same side that you are heating. This is a little trickier as you must heat the hole, remove your iron tip quickly, and then trigger the vacuum. We can now put the LED back in. If there is excess solder left on the component you pulled out, simply use solder wick to clear off that solder to fit it back into the holes. I hope you enjoyed these techniques and tips, and I hope they help you in your future soldering endeavors. Thanks for watching.